Well, this started out when I was working on my master's degree in agronomy, and my subject of study was decline in crops. Okay, what makes crop yield decrease over time, and what causes decline in trees? And I worked in Hawaii for a major companies in Hawaii to determine what was causing decline in macadamia. Okay, so my whole issue was why can't we maintain yield over time versus, let's say, slash and burn agriculture, or why do the yields go down over time, and how can we eliminate that? What are the limiting factors? There's limiting factors behind this, and what are they? And that was my project, to identify those factors. And the limiting factors that we determined based on other researchers like Dr. Vladimir Metachenkov, who was a member of the Russian Academy of Agricultural Science, and he was on special assignment to the Florida Institute of Agriculture. And the project was decline in citrus trees. Why is the million-acre citrus industry in Florida, reduced yield, quality, sugars, all those factors were going down? At the same time, I was working with crops in Hawaii. Same issue. Macadamia crops, decline in trees. Okay, so exchanging information and products, and we realized that the main limiting factors on a given soil was a lack of amorphous monosilicic acid and activated humic compounds. So in other words, soluble organic matter and a soluble form of silica. And so we found out that if you clear a rainforest, or any forest, it could be an oak forest here in Oregon, initially you have a fairly high availability of silica, silicic acid, in a form that's available, that can be translocated by plant roots. But it had to be in conjunction with fulvic acid, or humic acid, because humic acid is defined as soluble organic matter, and it's the living link between a dead mineral and a living root. Okay, so you had to have an intermediary organic component between an element like silica or phosphate and a plant root, which is a living cell, really. It's really living cells. So it turns out that after years of research in Florida and Hawaii by me, that it was determined that the main limiting factors in any given situation are lack of silica and in the form of monosilicic acid and activated humic compounds. And so we found out that when you replace those substances, you not only got better growth, you had resistance against diseases. Like, for instance, even viruses were reduced. Insect damage is reduced. And part of the reason is the silica is absorbed by the plant and tends to almost armor plate the leaf surface, the epidermis, with a substance which is defined as opal, which is another form of silica. Now, what's complicated about silica is it's got so many different forms.